Hey, Wada here, and I wanted to share an example of how I can solve some kite building problems with 3D printing. I built an Itrix a little while ago, and I'm working on a new indoor kite that's going to be my own design, which starts off with the Itrix and just scaling it up as the first iteration. I'm going to make some more changes later on after testing this. But there's one thing that I've noticed, which the Itrix that I built has a single piece lower spreader. And that ends up being a fairly long rod, but it's okay because the kite's pretty small, and so even with that long rod, it still fits in that hard case behind me. But since I'm taking a similar design, the same design, and scaling it up, I can't really do a single piece lower spreader anymore because then it won't fit in my bag, and I need to be able to travel with it. So I need to be able to take that lower spreader and break it up into two pieces. Now, I use two-piece lower spreaders all the time when building outdoor kites, right? You take an inner ferrule, you ferrule one of the lower spreaders, you put it through a little cross-fitting like this guy, and then put the other spreader on the other end, right? Simple enough. The problem is, for this indoor kite, I'm using some pretty small rods. I'm using this 4mm diameter protruded carbon. Now, the interior of that's pretty small. So I'm concerned about the strength of that approach in that an internal ferrule wouldn't be very strong. So I think that idea is out. Now, another way that I could do this is with a bit of aluminum tubing like this, right? You could take the aluminum tubing, put it through the cross-fitting, and then maybe cut this down to reasonable length, and then just shove the lower spreaders in either end. And I've had kites that do this. I've seen this done. And it seems okay. The one thing I don't like is that aluminum obviously isn't very grippy, right? This is just can slip right through, no problem. So I've had cases where the lower spreader came off in flight, and that's no good. So I'd like to maybe come up with another idea that avoids that sort of problem. A third option I've been thinking about is an all-in-one fitting, right? Where I do a cross-fitting, sort of like this guy, but instead of putting a ferrule through there or putting aluminum through there, what if I took sort of a leading edge fitting, right, in this kind of approach where you have this guy, and did that sort of thing, right? So I have that on either end, so the rod can fit in there. This is kind of squishy, so it can grip onto the rod. So hopefully that would prevent the rod from slipping out. But there's still a few concerns there. One, all of that plastic might be a bit heavy. I've done some napkin math, and I think it'll be pretty similar to the sort of aluminum approach, but I don't know. We'll see. Another concern is if, depending on how flexible this is, having a internal ferrule or using an external ferrule with like the aluminum rod will keep the two rods straight, right? If this is too flexible, then it could flex out and that could change the shape of the kite. So maybe that'll be a problem. I feel like I can get around both of these. I don't think the weight's going to be too big of a deal. And with it being an indoor kite, I don't think the pressure on that tee is going to be a super big problem either. But I'm going to build both the aluminum solution and the all-in-one plastic fitting solution and see which one I like more. So let's get started with the 3D modeling. I'm going to start with setting up the fitting that I need for the aluminum solution, because that should be pretty simple. So I'm going to open up my spreader spine cross-fitting Fusion 360 project. So this is Fusion 360. This is software for 3D modeling, right? This is where you create a 3D shape that you want, that I'm going to use for 3D printing. So in this case, I have a few here. I'm going to look at primarily this guy. This is a parameterized version that I've built, which all that means is that basically I've reduced this model down to some variables. So I'm going to open up the parameters window, and here I basically have a bunch of parameters set up to control this model, and the main two are the spine diameter and the spreader diameter. So in this case, I know the spine is going to be 4mm protruded carbon, so that should be 4mm. Let me grab my calipers and I'm gonna measure that just to be sure. Yeah, we're working at 3.94, so 4mm should be fine. And then for the aluminum bit, I'm gonna use this aluminum. I'm gonna cut it down later. And this guy is going to be, this is 6.36. So I'm going to put that at, say, 6.5. I can always print it again and adjust it later if I need to. I want it to be somewhat firm. I want to have a good grip, so I don't want to make too much tolerance. But yeah, so we got 4 millimeter by 6.5 millimeter, and you can see the fitting changed, right, accordingly. So cool, done. That guy's ready to go. But that's also, while we're in here, I'm gonna also set up the new fitting. So I'm gonna do this. I'm liking the idea of keeping all of my models that solve the same kind of problem in the same file. So I'm just gonna create a new component for it. This is gonna be the all-in-one fitting. Sure. Right. Okay. So now we've created a new component called the all-in-one fitting. All right. So let's think about how we want to structure this, right? It's going to be kind of similar to this guy, except over here it's going to spread out further. So let's kind of start with that. We're going to make, we're going to start with a sketch. So I'm going to go and make a sketch. We're going to do it on this axis here. Cool. I'm going to do it somewhere over here away from all this other stuff. I'm going to start with a rectangle. So let's think about how big we want this to be. So I know I already have some variables set up that I just used, so I might reuse some of them. But I know, let's start with sort of the spine, right? If we assume the spine is going to be 4 millimeters, right? So that's going to be spine diameter, right? That'll be 4 millimeters. And we want some walls, right? There's going to be a hole, and then there's going to be walls on either side of that hole. And I think I have a variable in here for, yeah, spine wall thickness, but there's 2 of them. So I'm going to put parentheses around this. I probably don't need to because of order of operations, but I like to be explicit. Right, so now the width of this is our spine diameter, which is 4 millimeters, and 2 times our spine wall thickness, which spine wall thickness is just a variable that's like, I forget what it is, like 30% of the spine diameter, something like that, to set up a reasonable wall thickness. And we're gonna have 2 walls, right? Okay, so there's our width. For our length, right, we have another, let's see, we have 1 spine wall, we have the spine, we have another wall, and then we have our spreader, and then we have the spreader wall. So I'm going to call this guy, we're going to go spine wall plus spine diameter plus, here we could choose either the wall that's intended for the spine or the wall that's intended for the spreader. It should be the same in this case since it's a 4 millimeter rod in any case. But I'm going to use a little formula here called max. I might have a, yeah, so I'm going to choose whichever is biggest. So I'm going to go max spreader diameter, no, not spreader diameter, spreader wall thickness, and spine wall thickness. Right, so now we've got 1 spine wall thickness, 1 spine diameter, and then the max, whichever's bigger, between the spine wall thickness and the spreader wall thickness. And then we're going to have the spreader diameter, right, because we have wall, spine, wall, spreader, and then another wall. So we're going to go spreader wall. Right, cool. So there's a rectangle, right? That's kind of going to be the overall shape. We'll also have kind of some wings here, so maybe we can draw those out, right? So this is going to be a rectangle. This guy is going to be spreader diameter, right? Because this is supposed to hold the spreader, so it needs to be at least the spreader diameter. And it's going to have 2 walls, just like the spine case, right? We're going to have spreader wall times 2, because there's 2 of them, right? So there's that. And then this one, I don't know if I have a good variable for this. We can make one later if I need to. But this will be, how long the hole should be, right? So for now, I don't know, say 10 millimeters. Does that seem reasonable? That looks, this looks really wide. What's up here? Spreader diameter plus spreader wall thickness times 2. Oh, okay. This looks weird because our variables are set up for the other one. But that's okay. We'll just change the variables before we export this. So the reason I'm making this fitting with a 4 millimeter spine and a 4 millimeter spreader, but we're using the same variables that I used for the aluminum fitting. So we're currently set up with a 4 millimeter spine and a, what was it, 6.5 millimeter spreader, basically. So that's why it's going to look a little weird, but we can adjust the measurements later. 10 doesn't look very proportionate. I'm just going to call this like maybe a factor of the spreader diameter. Let's go spreader diameter times 4 or something. Well, that looked like too much. Okay, let's go maybe times 3 instead. Something like that. Yeah, that seems more reasonable. All right, and then we're going to do the same thing on the other side. So rectangle, boop. Make this guy, this is going to be our spreader diameter plus 2 times spreader wall. Cool. And then our other one was spreader diameter, spreader diameter times 3. Cool. All right, so we have our sort of 3 rectangles here that can kind of represent the top-down view of the fitting. So I'm going to finish the sketch. Cool. You conveniently moved me away from my part. Okay, so now I'm going to hit E. I'm going to extrude. So we're going to highlight all these bits, and we're going to pull it up. So I'm going to take this little arrow and just go brrr, right? So now say it's created a 3D shape. That's just a block in that shape that we defined. Now, how tall does it need to be? So here we're thinking about the spreader primarily, right? The height of the thing needs to be the spreader wall thickness plus the spreader wall thickness. So we're going to go spreader diameter plus spreader wall thickness times 2. Right? Cool. So there's our kind of blocky example of our fitting. That's fine. So we're going to drop in, let's do some, you know what, actually, I forgot to do a thing. I'm going to Control Z, we forgot to put the circle. I need to put a circle in there. So I'm going to edit this sketch some more. Because we're going to need a spine, a hole for the spine, right? So we're going to make a hole here. This is going to be spine diameter. Okay, cool. So there's a circle, but just to make sure it's the right positioning, I'm going to go distances here. So I'm going to define this distance, right? The distance from this wall to the center of that hole should be the spine wall thickness plus half of the spine diameter, right? Because we're going to the center of the circle, so that would be the radius instead of the diameter. So we're going to spine diameter divided by 2, right? So that'll center it horizontally there. And we want to do the same thing here, right? And so this guy is going to be the same thing. This is going to be spine diameter divided by 2, spine wall thickness plus spine diameter divided by 2, otherwise known as spine radius. That doesn't look right. What did I do there? Spine wall thickness plus spine diameter divided by 2. No, I guess that is right. That's the same. So maybe this guy's, what did I do here? What are these guys? Spreader diameter. Oh, that's what I did wrong. I'm double counting. Well, no, that's fine. We can maybe tweak this a bit later. That's fine. We'll see how this goes. Okay. So now I'm gonna finish the sketch again. Right. So now I've got it like this. So I'm gonna select everything. Just like that surface, this surface, this surface, not the circle, right? Because I want to keep the circle. I'm going to hit E, and I'm going to extrude that up, and that was, again, we were doing spreader diameter, plus spreader wall thickness times 2, right? Okay, cool. There's our really weird looking fitting for now. In fact, I'm going to change the parameters real quick, just to make this make a little more sense. So we're actually dealing with 4 millimeter by 4 millimeter. Cool. Right? Nice. So we've got this guy. So we can do a few things here. I still need to punch holes here, right? So I'm actually going to go with, let's go with a sketch. I'm going to make a sketch. Yeah. Go into this guy. We're going to put a hole. I'm going to put a hole right centered in here. Will it let me center that? I don't think it's going to. So let me do a rectangle so that I can have some pretty clear dimensions. I'm going to put a rectangle around that I can reference really easy. I'm going to call that spreader diameter. Cool. And again, we want to center this guy, right, by spreader wall thickness plus spreader diameter by 2. Right, so that'll center it vertically, and then we also want to center it horizontally. Spreader wall plus spreader spreader diameter divided by 2. Cool, so that should be force centered. So we'll finish that sketch. And then we're also gonna do the same over on this guy. I'm gonna do another sketch on this one so we can have another circle to match. In fact, I wonder if I can just have it reference the other sketch. Can I do that? Ooh, I think I can. Cool. Spreader diameter. Perfect. And hopefully that should automatically stay centered because it's sort of, I'm hoping that that's matched to the other one. I'm not really sure. We'll find out. Finish sketch. Cool. So we've got 2 circles here. This guy, I'm going to hit E and extrude that. And instead of pulling it up like I did before, I'm going to push that in. Right? And now we're making a hole. And we had decided that the hole length was going to be spreader diameter times 3, right? But that's pushing it out, right? I need it to be a negative number, so I'm going to multiply by -1 as well. There we go. So now we have a hole that goes in just the length of this guy. And we'll do the same here. Right, we're doing spreader diameter times 3 times -1. Right? Cool. So there's our thing, but it's really blocky and ugly. So let's make that nicer. So I'm going to start by beveling these. Right, so I'm going to make these round. Right, so if I push this arrow, you can see it's going to make these corners rounded. And we're going to round that by based on spine diameter times 0.5. No, just spine diameter. Is that right? I think it looks right, but I think that's just a coincidence because of the wall thickness. So what I think I actually want is spine diameter plus spine wall. Spine wall. Come on, if only I can type. Wall thickness times 2, right? Divided by 2. That's what we want, right? Because we want the whole width of it. We want to round it in halfway on either side, right? So the whole width of it is the spine plus 2 spine wall thicknesses. So we add that up and then divide that by 2 to get that fully round the circle, right? When I just did spine diameter, that also did it. I'm guessing that the wall thickness I have set up is 0.5, right? Which would mean that the overall length is 2 times the spine diameter. So if I set the spine diameter, then it does the half, right? And then we want to do the same thing with these guys, but based on based on the spreader diameter. So I'm going to grab all these corners, grab this guy, and this guy, and this guy, right? And again, I'm going to bevel. So let's bevel. And we're going to make that be spreader diameter plus spreader wall. Oh, I don't want to put parentheses around this. Spreader wall times 2, 5 by 2. Boom. Cool, right? That's looking more like a thing. For ease of getting the rods into here, let's also chamfer this guy. So chamfering is kind of like beveling, but more on a straight line. So we're going to call that, I don't know, what happens if I set that to spreader diameter? Is that too much? That's too much, apparently. 5 by 2. Okay, so spreader diameter divided by 2 will give me a full chamfer. I want a little bit less, so I'm actually gonna multiply it by 0.4. Right, multiplying by 0.5 would be the same as dividing it by 2. So I want to just do a little bit less, so it's a little easier for me to do it this way. Yeah, let's go maybe 3, 5. 3.5. That's cool. Yeah. Right, so that'll make it a little easier for me because I'm going to be shoving the rods in and out of here all the time. So that'll make it a little easier to deal with. Cool. And I think that's about it. I mean, I can do some other cleanup, right? I can, just for the sake of making it look pretty, I can like, you know, bevel this guy by some like tiny amount, like 0.5 maybe, 0.5, something like that. This makes it a variable of the spreader. Spreader diameter times 0.1. Cool, that looks fine. Right, so now that's kind of got a rounded bit. Sweet. Yeah, and then one thing I didn't really like was I don't like how tight this is. This spine's gonna come up here, right? There's like no clearance between the spine and these guys. So, and you've got some fabric in there. I don't want it to be quite that tight on the fabric. So I'm gonna adjust that when we made this sketch, right? We made this guy, this guy. There's our whole equation there, right? The spine wall thickness plus spine diameter plus whichever wall thickness is bigger plus spreader diameter plus spreader wall thickness. But let's add a little bit of tolerance in here, right? So I want a little bit of space between when the spreader wall thickness starts, between the spreader wall starts and the end of the actual spine rod. So let's add, I don't know, just another 1 millimeter or something, just a little bit. Is that something like that? Cool. Yeah, not just adjusts and then finish sketch and it'll speed back up again. And there we go. So now we have a little bit of space between that wall and the spine. Cool. So I think that's good to go. Yeah, well, maybe let's make that hole a little deeper too, because I don't like how, well, nah, that's fine. I'm gonna leave it there. I like having the extra rigidity in here. I think that'll be kind of nice because I was concerned about the flexing. So what I was thinking about was making this hole, right, this hole deeper, because there's a lot of space in there, but I think that's basically good because that'll be all filled up with material and that'll help make it more rigid to prevent that sort of flexing that I'm concerned about. So yeah, that's it. So we'll go and we'll export these. So I'm going to start by exporting this guy, right? We're going to 3D print these. So I'm going to take this guy, save as STL. Now an STL is just a file format for a 3D model. So we're going to print this guy. I'm going to hit OK. Come on. And there's a way that I can send models directly to my slicer, which I'll explain the slicer here in a minute. But I'm just going to save it as an STL because I'm going to upload these to my website as well. This whole Fusion 360 project is available on my website as well, and I'll have a link for that in the description. But I'm going to save this guy all in one fitting. Perfect. I'll get with that, understand what that is. And then remember, we need to change the variables again if we want to export this parameterized cross-fitting. So let's change the parameters back. That was, let me measure this again. What was that? Oh, I dropped a rod. 6.5 I think I had it at. But is that, what was it, 6.36? 6.37? I'm gonna actually change my mind on that. I'm gonna put that at 6.4. I want it to be tight, right? I want the aluminum to just be stuck there. So I'm gonna call it 6.4. I want it to be a little tight. Cool. And we can see that our other one changed too, right? Because we're using the same variables, so that's kind of cool. But anyway, let's save this guy as an STL as well. Parameters cross-fitting, cool. I'm just saving in my downloads folder because that's where I save things that I don't really care about because they'll get deleted eventually. Cool, so we've exported those things. So I'm gonna now open Cura. Cura is my slicer of choice, Ultimaker Cura. Now, what is a slicer? A slicer takes a 3D model, like we just made, and creates plans for my 3D printer, right? It tells it where to put the print head, at what time, when to push material out, what temperature to set the material at to melt it appropriately, all these sorts of things, right? The slicer creates a file that called a G-code file that I can give to the printer that will explain to the printer how to make our object. So here's Cura. So I'm going to start by just pulling in those two files that I just created, those STL files. I put them in downloads. Yeah, you can access downloads. Cool. Let's see here. So we had all-in-one fitting and parameterized cross-fitting. Okay, cool. Remember those? All right, there they are. Here's on my kind of virtual print bed. It looks kind of dumb, but that's fine. Okay. Now here I have a ton of settings. Right now I have my PLA defaults selected. I don't want that. I want to print this in TPU. There's a lot of different printing materials. PLA is pretty cheap and easy to print with, and but it's a rigid material, and I don't want that. I want something with at least a little bit of flex. So I'm going to be using a 95A TPU, and so I have some default settings that I have set up for that. Now TPU is a slightly flexible material. That's what this is. This is printed in TPU, so I use this for a lot of things, and it's red and shiny, so that's nice. So there's a ton of settings in here, right? Our layer height, which is how thick of a layer it's going to put, when it squeezes out extrudes the material, is how thick that line's going to be. Our wall count is how thick the wall is going to be. Right? If you have a cube, for example, your wall is just sort of the perimeter of that cube, the outermost layer. And then you have infill, which is sort of the density inside it, so you have a different pattern there. I don't want to do 100% infill, I don't think. I think that's going to be a little bit too stiff. I'm just going to come down to like 80? I don't know, something. Oftentimes I do 50 on like these sorts of guys, but again, I was concerned about the flexibility of those pieces, so I don't want to go quite down to 50, but I'm going to go 80 or so. I can try this again if I don't like it. So I'm going to hit slice, and we'll see what that's doing. I can hit preview. Alright, so here's what it's going to do. It's going to go around the circle. So we can go all the way through this. It's going to go around the circle. It's going to get that. You can see this sort of darker orange, right? That's our infill, right? So it's not filling it 100%. It's leaving some gaps, right, every single time. So it's not as dense. I might go a little bit less. Let's go like 70. What's that look like? Oh, I gotta hit slice again. Okay, cool. Right, so you can see what it's doing as it's gonna go through this whole thing. Right, cool. So that looks fine. So we're gonna save this to a file. I'm gonna grab my SD card. I just put it on a little micro SD card. Drop it in my SD card reader and plug it in. And we're gonna hit save. Well, let me double check these settings real quick. I think this seems fine. I might lower the wall. No, that's fine. Whatever, that's fine. Oh, save to removable drive is what I clicked. So it just automatically saved onto my thumb drive as CE3 parameterized crossfitting. That's fine. And I'm gonna eject that. Cool, so that's it. So we just created 3D models for both of these fittings that I'm gonna make. And we created the G-code files. We put it in the slicer and came up with the plans for the 3D printer and put it on my SD card. So now we'll move a little bit closer to the 3D printer and we'll print these. All right, so I'm at my 3D printer. I'm gonna start, we got my SD card here. There's a little hole in the front. I'm just gonna shove my SD card in there. And I'm gonna turn this on. All right, so right now I have PLA loaded into this. This is just what I was printing with before. So I need to swap that out and put in my TPU instead. So I just changed the filament. It just purged out all of the old PLA and some of the TPU to go with it to make sure we got all the PLA out. So I'm just gonna clip off. All right, here's the bit of stuff that I purged out. So I'm gonna throw that away. And then I could go and level the bed. That just takes a couple minutes, but I've done that recently, so I'm not gonna bother doing that again. So I'm just gonna come in, go print for media, and what did we name that? CE3 parameterized, there it is. I'm gonna click on that and hit print. Right, so now it's heating things up, and I can just leave it. It's gonna go and do its thing. So we still need to cut down some aluminum for that aluminum solution. So let's go do that. Okay, I'm over here by one of my work tables, and I'm going to use a newer tool that I just got recently, which is pretty cool, which is a little bitty table saw. Look at that. Isn't that adorable? Okay, so we're going to use this little bitty table saw to cut up that aluminum tubing. Once I stop screwing with the camera. Cool. So here's my tubing. It's kind of long. I'm figuring like if that's about half, a quarter of it seems fine. I don't know, whatever. So I'm just going to measure that out. Right, I got a ruler down here, and I'm going to mark it with a Sharpie. So how long is this? This is 12 inches. So that'd be 3 inches. Will be our total length. So I got a little mark for that. I'm going to figure out where this wants to sit. I'm going to set up a little guide so make sure I have it where I want it. In fact, it's just barely too long for my guide, isn't it? Yeah, it is, so I can't use the guide. That's fine. Cool. So, safety first, safety glasses. They look dumb, but whatever. And some gloves. I'm cutting metal, so might as well. And there's our piece, right? It's gonna be a little bit rough, so I'm gonna take it over to the Dremel and soften those edges. Okay, so now I've got my Dremel with an abrasive brush bit, right? So safety glasses again, and we're gonna just kind of soften down these edges, deburr them a bit. Cool. All right. So I just finished cutting that aluminum piece, and I'm back at the printer just to come and check on it. Let's take a look, see what it's up to. Looks like it's doing all right. So we'll give it some time. We'll come back in a bit. Okay, so we've gotten the two prints. Here's the aluminum one. I went and shoved the aluminum into there. It fits pretty snugly. It's, I can move the aluminum, but it's not too bad. And then we've got this guy, right? That would sit on the spine and all of this. It holds on to the rods well, so that's nice. But it is flexing a little more than I was hoping for. I think that might be a problem. So that's one problem. I've also weighed them. This guy is sitting at about like 3 grams or so, and this one doesn't even register. It's like 0. So I think I might kind of make some more changes on this model, kind of maybe make it a bit bulkier in the middle to kind of give it a bit more rigidity and keep it from flexing in that way. So I'll play with that in my own time. So it's the next day. I've been thinking about this fitting and this whole problem, right? And I've tried a few things to kind of help with the flexibility of this. I tried making it a little bit bulkier, and then a little bit bulkier still, but it's still just too flexible, and I don't like it. So I was trying to think about how I can have my cake and eat it too, how I can have something with the rigidity of this aluminum, but still have the grippiness of the printed part. So I did this, right? So I made a new model that basically has a hole that goes all the way through it that changes diameter in the middle here. So on this side, the diameter fits my 4mm pultruded carbon, and on this other side, it fits my aluminum. So I can shove this guy in. It takes a bit of effort, so we've got some grippiness, but I've still got the rigidity of that aluminum, and it seems like this is going to work pretty well. I might make it a bit smaller, maybe, and then cut down the aluminum size so that it just kind of fits with this piece and these other pieces being flush against each other. But I think that's gonna solve my problem. It's gonna give me the rigidity that I want. It's gonna give me the traction that I want. I was thinking that maybe I'd have to super glue this guy onto the aluminum just to make sure it holds, but I actually haven't been able to take it off. If I got some pliers, I could probably pull it off, but it's sitting on there pretty good, so I don't think I even really need any pliers or anything. But I'm gonna have to get some so I can take it off and make it a slightly smaller size. I think it's a little longer than I need. But yeah, so I think that'll work. That's gonna be my solution moving forward, I think. So thank you for coming along with me on this journey. I hope you learned something. I'm gonna have links down in the description for getting to these cross-fitting models, and also this model. What did I call this model? I called it a gripping joiner. I don't know. It's hard to think of words. So I'll have these all up on my website, and I'll put links in the description. So yeah, thanks for coming along.